Hey everybody. Okay, so the point of today's little discussion is to learn a little bit more about the atom and how it relates to the periodic table of the elements, which you'll hear me refer to as the PTotE, just because I think it's fun to say and it's a little bit shorter to write. Anyway, so the first thing I'm going to take you through is just sort of the basic structure of the atom with some details about it, and then after that we'll connect that to the periodic table, and so you can start using the periodic table to actually learn some useful information from the periodic table. Okay, so let's go ahead and fill this in together today. So the first thing that we know is that the particles in the atom, or there's 3 particles in the atom. And again, the order doesn't really matter, but in general, I usually put, in this case, we'll do protons, neutrons, and electrons. Okay, so those are our 3 particles generally that we think of as the structure of the atom. Now let's talk about their different charges. So this is important in terms of understanding why the atom stays together the way it does. The proton's charge is positive. This means that in terms of like electric charge, it has a positive charge. And then the electrons are negative. So most of the time, protons and electrons balance each other out. So most things in the world don't have a charge at all. And so then neutrons, kind of the way they sound, are neutral. No charge. This is why the neutrons and the protons can stay together in the nucleus so close, because they don't have any charges battling against each other. And this is also why the electrons stay in the atom, because they're attracted to the protons. Electrons are negative, protons are positive, opposite charges attract. So those electrons want to stay kind of near the protons, but because the electrons are moving so fast, they don't get like sucked into the nucleus. Okay, so speaking of nucleus, the protons and the neutrons are both in the nucleus. I'm going to save myself some writing here. So the protons and neutrons are both in the nucleus, and then the electrons, are in the electron cloud, which is around the nucleus. Flying around in that electron cloud, kind of get that visual there. Now the next thing we want to think about is their relative size. Now the reason I put relative size in there is because really when you think of protons, neutrons, and electrons, they are so crazy tiny that we really can't even describe how tiny, 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 tiny they are. But relative or related to each other, we would say that the protons and the neutrons are considered to be the bigger particles, and the electrons are considered crazy small. So it is the protons and the neutrons that generally make up the mass or the heft of the atom. If you could imagine holding it in your hand, it would feel the way it does because of the protons and the neutrons. The electrons, like I mentioned before, make up the size of the atom. From floating around the nucleus, they sort of dictate how big the atom is going to be. So that's just sort of a little relative idea to think about. The last couple things I want to talk about is, okay, so then what happens if you lose one of them? Now, if you lose a proton, the proton is the thing that defines an atom. So if you lose a proton, you get a whole new element. This is in fact how they make new elements, by trying to change the number of protons, splitting them up with energy, that kind of thing. So protons are how you get a new element. If you lose a neutron, you don't really change anything about the identity. It would just be a lower mass. You still have the same element, it's just that it would have a lower mass. And if you lose an electron, now here's the part that's a little bit tricky. Maybe you remember this from before. Electrons are the thing that determine the charge of an atom. So if you change the electrons, you affect the charge. And because electrons, remember, have a negative charge, like we learned above, since electrons are negative, if you get rid of one, you get a positive ion. Remember, an ion is an atom with a charge, so we call it an ion. So electrons are something that affect the charge. And because electrons are negative, if you get rid of one of them, the leftover thing is positive, right? Think of like attitude. You get rid of a negative attitude, you're going to have a positive attitude. So then let's go on to the next one, which says, well, what if we gain one? So just making sure that these are clear. So this is what happens if you lose. This is what happens when we gain. All right. So if you gain, you still get a new element. If you gain an extra proton, it would just be a higher mass element. And then same with sort of the idea with the neutrons, you would now have a higher mass. And I'm going to introduce the word isotope here. Let's go ahead and add that in there. It's a higher mass isotope or a lower mass isotope. So if you lose a proton, if you lose a neutron, you get a lower mass isotope. If you gain a neutron, you get a higher mass isotope, just to make sure that that is clear to you. Okay, so now we'll be back to the electrons. Remember, the electrons are the thing that determine the charge, and electrons have a negative charge. So if you gain an electron, you are now going to have a negative ion. This will be useful when we start talking more about bonding and writing formulas, when we talk about oxidation numbers, what's its charge, plus and minus. So electrons, when they lose, or atoms, when they lose electrons, are positive. Atoms, when they gain electrons, are now negative because of that negative charge. And then the last thing is, okay, so how do we figure out how many there are? So how many in an atom, how many protons? This is the same as the atomic number. And we'll learn more of that in a little bit. The neutrons then, this one, what you do to figure out the neutrons is you figure out the mass number, which we'll learn about in a little bit, and you subtract the protons. I'm going to do a little P plus for protons. So to find the neutrons, to figure out how many atoms are in a neutron, or how many neutrons are in an atom, you take the mass number minus the protons. And then the electrons are usually the same as the protons, unless there's a charge. So I'm going to put that sort of in parentheses down there. So unless it has a plus or minus charge, then you would either add or subtract electrons based on what the charge is. So to review up here, so if it is a positive charge, let me change my color here quick. So if it's a positive charge, you would subtract electrons, right? So there's less electrons than before. If it is a negative charge, then you would add electrons because there's more than there was before, if that makes sense a little bit. We'll practice that and you can clarify as needed. Okay, so now that scientists, after they figured out all of this stuff about atoms and periodic tables, now that they understood the atom a little bit better, they could start to be more specific about explaining the patterns in the arrangement of the elements. The essential difference between atoms is their number of protons. The atomic number, called that because it's the atom's number, is the thing that defines it. For example, we'll always think of Michael Jordan as number 23. That was his athlete number, right? So that's how we think of the atomic number, is the thing that tells us what atom we have. All right, so here's some other terms that are going to help you learn to use your periodic table a little bit more. So let me just go through this a little bit, all right? So the chemical symbol is just going to be the letters, right? So if I'm asking you for a chemical symbol, all you need to know is what the letters are. And remember, PTotE is your periodic table. You can either use your app on your iPad for your periodic table, or I've got laminated ones that you can use in class as well. So chemical symbol is just the letters. If I'm asking you for whatever reason to give me the atomic mass, this is going to be that decimal number on the periodic table because it's an average of all the different isotopes put together, so you can end up with a decimal for the atomic mass. Think of it as kind of like the mass of the atom, that kind of idea, all right? Now, the reason we'll use it sometimes is that if I don't give you the mass number, you can round the atomic mass to find the mass number, so that will be kind of useful later. All right, another thing that will be useful is if I give you the atomic number, remember that's going to be giving you the number of protons. Or if I don't give you the number or the atomic number and I ask you for the atomic number, you can find it by using the number of protons. So that's the relationship between atomic number and number of protons. And then one more here is our mass number. So mass number is what we use to find the neutrons, remember. So that's kind of what the purpose of the mass number is. And there's 3 versions of it. So sometimes I will just give it to you in what is known as the isotope symbol. A definition of isotope is an atom with a different number of neutrons, so that changes its mass number. So sometimes I'll just give you the mass number. Another thing that I can do is you can take the protons plus the neutrons to find the mass number, because that's the definition of mass number. Or the other option is, like I told you here, you can take the atomic mass and round it to the nearest whole number, and then that will give you the mass number if I don't give it to you. But always try to use the given version if you can. So that's some information that's going to help you understand your periodic table a little bit more. So as a chemist, the periodic table is super useful. Today, you're going to use it as a tool to describe the atom in terms of the number of protons, number of electrons, and the number of neutrons, and the atomic mass. Because the more we understand the tiny things in an atom, the more we can explain the way the atoms react, the way they look, the way they change, all the things they do. And that's what chemistry is all about, understanding the little things to try to explain the big things. So what I want you to do now is I want you to use your periodic table to fill in the stuff below. Element, symbol, atomic number, mass number, protons, electrons, and neutrons. And I do want to point out something really quick. Notice that these two are the same idea, but notice that they have a plus or minus charge. So that's going to possibly affect how you fill them in for just one of them. All right. And let me give you a little bit of hint, help you. Let's just do, I don't know, let's pick an element here. Let's do carbon, because I think that's not one that I was going to have you do. So let's say that carbon was the element that we were going to do, and let's say that carbon happened to have a mass number of 14. So that was my given information. So let's figure out how we would figure this out. So because I gave you the letter C, that's how we know it is carbon. So you would use your periodic table to just find the letter C and say, oh, that's carbon. The atomic number is the whole number on the periodic table. So when you find that, you'll see that that is 6. The definition of atomic number says that also tells us the number of protons, so then that means the number of protons will also be 6. The atomic number tells us the number of protons, which almost always is the same as the number of electrons. Because there's no charge, that means that electrons and protons have to be the same. So because the electrons and the protons have opposite charges, they have to be the same if the atom has no charge. So in this case, this was no charge, which means that the atom itself is neutral. And then remember, to find neutrons, this is the one where you got to do a little bit of work. So what you're going to do to find the neutrons is you're going to take the mass number minus the protons. So the definition of neutrons is mass number minus protons. So if we look back at our example, the mass number that I gave you was 14, the protons was 6, so 14 minus 6 tells us that the number of neutrons in this example is 8. All right? So I want you to do that for the rest of those boxes above, asking for help as needed. When you're done, show me. And just to sort of give you an idea here, I know that sometimes one of the things that can be tricky about chemistry is that it's so much little details. And so one of the things that we'll be doing in our class is we are going to spend some time talking about little details so that you can understand sort of the bigger ideas that are going to be coming later. So bear with me. Chemistry's in the details. It's what makes all the other stuff important and super cool and interesting. So continue working on this. Let me know if you have any questions. Otherwise, thanks for listening.